Hi everyone. So my final project is an agentic AI application, specifically a financial research assistant that automates investment research. Investment analysts spend many hours a week gathering data. A single language model call cannot solve this. It lacks fresh information and conflicts analytical dimensions. The solution, an agentic AI framework where feedback loops and quality gates coupled with good prompt designs produce reliable output. So the technology uses six core packages: radio for the interface, the OpenAI Agents SDK, ChromaDB for persistent memory, and the OpenAI and TOEFL APIs for reasoning and live web evidence, all running on a local disk with no GPU required. So this application has 8 agents collaborating with each other. Okay, so it has 5 phases. So the first phase is domain check. Next one is memory recall. And then the next one, an iterative research loop, writing, and finally a self-correcting critique loop. Okay, so the first a gut rail firstly a gut rail checks whether the question is even in the finance scope. Second, a memory recall phase looks up relevant prior research from a vector database. Third, a dynamic research loop plans and executes searches iteratively until it's confident it has enough information. Fourth, a self-correcting writer drafts the report, critiques it, and revises it. And fifth, the final session is saving the reports into memory for future recall. So what makes this agentic AI is it has the following characteristic. The application has autonomy, tool use, goal-directed behavior over multiple turns, reasoning about its own state, and it has multiple specialized components collaborating with each other. And lastly, it has persistent memory across interactions. So let's take a look at the application first. So this is how the application looks like. So you can put any query into this field. So let's say I want to say uh, do a do a deep dive analysis on the current geopolitic geopolitics condition in the Middle East. So let's wait for the response. So it says the gut rail is triggered and it requested the query because it's not related to financial. It's related to politics. Okay, but if we change the query to let's do a deep dive analysis on Best Buy's most recent financial results released in 2026 so far. See, it says that no prior research on this topic, so it's starting fresh, okay? And now it's doing iteration. So while the application is running, let's go back to our Jupyter Notebook first, okay? So this is how I structured the Jupyter Notebook. So basically, I break it down into 5 steps. The first one is the initial setups. Second is the creation of agents. Third one is the inter-agent communication loops. Next one is the setting up radio, and the last step, which is step 5, is running the application. So in the step 1, you can see the packages used in this project, like the Python, ChromaDB, Gradio, Pydantic request, and the OpenAI agents. Okay, and these are all the imports. And this is the parameter and LLM model configuration. So for this project, we use 2 LLM models. The small one is the GPT-41 Nano, and the second one is the GPT-41 Mini. The GPT-41 Nano is used during the domain guardrail phase. Okay, and this is how I set up the configuration for the Chroma DB. Okay, and I also have like a bunch of helper functions. Okay, so now let's go to the important step, which is the creation of agents. So, like I said, we have like 8 agents. So the first one is the domain guardrail agent. So the guardrails instructions enumerate in scope topics like equity research, valuation, macroeconomics, central bank policy, corporate earnings, and investment strategy. And out of scope categories are like medical advice, travel, creative writing, lifestyle, and etc. Okay. And then the next agent is the search agent. So the search agent owns the Tafeli web search tool. Given a natural language query, it returns a summary object with a single summary field capped at roughly 200 words. The agent's job is to extract the most relevant and recent information from the search results and produce a clean, readable summary. Okay. And the next one is the fundamental analyst agent. So this agent focuses on revenue, growth trajectory, and profit margins. It also has access to Tafeli search and creates a summary object. The next one is the sentiment analyst agent. This agent evaluates current market sentiment toward the company, drawing on recent news, social media, and analyst opinions. The next one is the competitor analyst agent. This agent examines competitive positioning using frameworks like Porter's 5 forces, covering market share dynamics, product differentiation, pricing power, and structural threats. And the next one is the reflection agent. This is a very important agent as it evaluates progress and decides what to do next. It creates a gap analysis object containing an is complete flag, a confidence score from 0 to 1, a one paragraph finding summary, a list of remaining gaps, and whether a next query is justified or not. Okay. And the next one is before we create the very last agent, which is the writer agent. This is how I built the writer tools registry. Okay. And now the last agent, which is the right. No, it is not the last one. This is the second to last. So this is the writer agent. So the writer is the central synthesis agent. Its instructions specify the report structure. The writer produces a final report object and has the 4 sub-agents, the search, sentiment, fundamentals, completed editors, analysis, registered as its tools. Okay. And then the very last agent, which is the critic agent, it reads the original query, the research notes, and the report draft. It then produces a quality score from 0 to 1, an overall assessment, a list of specific issues such as severity, category description, and suggestion, and a list of strengths the writer should preserve. Okay, the critics calibration is encoded in its prompt. 90% above is indicates publication rating. And now the third step is the inter-agent communication loops. So we have 2 control loops that execute most of the system's quality assurance task. So the first one is the dynamic research loop. The dynamic research loop alternates between the reflector planning agent and the search agent. The loop startup behavior depends on whether prior memory exists. Its iteration appends a research node to the running list, after which the reflector is reinvoked with the full set of past queries and nodes. The reflector instructions explicitly forbid duplicate searches. The loop ends when the reflector reports completion with confidence at or above 90% threshold. Okay. And the second important loop is the self-correcting writer loop. This loop alternates between the writer agent and the critic agents. After in initial draft, its iteration runs the critic on the current draft, updates a past scene tracker if the new score exceeds the previous past, and either accepts the draft score at or above 90% threshold or formats the critic as feedback for a revision. Okay. And next, this is uh, how I set up the Gradios. So as you have seen before, it has uh, two most important tabs, the research tab and the memory tab. So basically, this one is setting up the research tab functionality, and this one is setting up the memory tab functionality. Okay. And this is how it's setting up the user interface. So basically, let's go back to our application. So by now, it's already finished with the iteration of the research phase. So it only has one iteration because it just happens, fortunately, after one iterations, the confidence is already 92%. Okay. So it didn't do another iterations, but some iteration can have like 3 or 4 iterations. Okay. And then once it's finished the research phase, it goes to the writing phase. And this one also uh, in the first round, it already hit 92%. So with that, the draft is accepted because the quality score is already 90%. It just happens this example is good. Okay, but like when I ran other queries in the past, it did has like some iterations. Okay, so this is the final result. You can see like the executive summary and then the full report, and the full report has many sections like recent developments, financial performance, competitive position, market sentiment, race, outlook, and the follow-up research questions. Okay, and if you go to the memory tab stores every prior session for follow-up queries. So if you hit the refresh list, you can see that this is the very last query that I did, which is the query on best buys. Okay. So let's say you are interested in your past query, which is the buy to stock. You just click on that one, and then you click the load session. Now it will now it will retrieve all the by2 resource report that we had that we had done in the past. Okay. So basically that's how the application looks like. But if you want to see like what kind of function it runs when during the step 5 running the application step. Basically, it first runs the run app function and then runner.run and then recall relevant memory. The recall relevant memory queries the Chroma DB for prior research notes and reports related to the current query, and then format memory for prompt. Okay, and then this is and then the dynamic research loop kicks in, and the self-correcting writer kicks in, and then finally it saves the final result. So basically that's it. That's how I structure my Jupyter notebook and how I design the agentic AI for the financial research analyst assistant project. Okay, so it's quite simple. Okay, thank you so much. Bye.